everyone. My name is Partho Das, Assistant Professor, Department of Electrical Engineering, JS College of Engineering, West Bengal, India. So, welcome to my class. So, today as you can see, the topic is compensated series motor. So this compensated series motor, so this is basically a series motor that we have studied in DC machine chapter. So in DC machine chapter we have studied that DC series motor where field winding and armature winding connected in series. So that motor and how we can modify that one and how compensated winding is used inside that, and what is the utility of that one, and why we are using compensated winding in the case with the series winding, and then which problems we can overcome. So those things we are going to see today. Okay, so let us see what are the topics we are going to cover today. Okay, these are the contents. So introduction. So commutation AC machine, commutation in AC machine, um, compensated AC series motor, universal compensated motors, repulsion motor, advantages and conclusion. So these points we are going to cover today. So let us start. Okay, so what is introduction? What is written in the introduction? So historically, heavy duty commutator motors are known to cause problems like brush sparking, chatter, excessive wear or chipping overload. To address this, modern AC commutator motors are use an auxiliary structure called compensated winding. So in the previously, when DC machines are mainly used, so at that time when we are thinking of a large machine, so at that time, so we know that the commutator is connected with the brush. So now if there is any gap between this occurs in between the commutator and brush, so there will be air will be present over there, and due to that there will be a heavy sparking. Okay, so to reduce that problem, so we have introduced some compensated winding after after some years. Okay, this compensated winding is embedded in the pole faces of a commutating alternating current machine and connected in series with the armature. The magnetic field of this winding neutralizing the cross magnetizing effect of armature reaction. So we know that when armature reaction occurs in DC machine or any kind of machine, maybe DC, maybe AC, so the result of that one is that it destroy or it reduce the main field flux. So here we know that in armature reaction we have two kinds of effect, that is demagnetizing effect and cross magnetizing effect. So by using this compensated winding we can neutralize this cross magnetizing effect of armature reaction. The repulsion motor was found to have significantly lower stator field distortion. In case of series motor, the stability of the motor is also benefited on sudden load shift. Further improvements on the power factor of the motor can be done by adjusting the field reactance or decreasing the ampere turns of the field winding. So these are the points, these are the main characteristics we have in case of this compensated series motors. So let us start. Commutation in AC machine. It is the process of reversal of current in armature winding by means of brush and commutator segment. EMF induced in short circuited coil under commutation, reactance EMF, uh, rotational EMF, transformer EMF. Okay, so those EMFs are induced in the short circuit condition and in the commutator. Reactance EMF can be delayed the reversal of current in the commutation coil. So as you can see in the phasor diagram, so these are the different EMFs that is induced. So this is the main flux. Okay, so that is the armature reaction flux, that in this axis also main flux, in this axis the armature reaction flux. Okay, at the same time we have the E1 and E2 also in this axis, and E3 is 90 degree shifted from that one, and that this is the resultant of this EMF. So E resultant is given by under root E1 plus E2 square. So this E1 E2 square, okay, plus E3 square, that is giving us the result. The resultant EMF is given by this, okay, and this is the phasor diagram that we have discussed. The resultant voltage ERT causes the flow of the circulating current in commutated coil, leading to bad communication. Okay, next, commutation in AC machine. Compensation requires for better power factor, better speed torque characteristics, improved communication. Sorry, commutation. So these are the advantages if we can get if we use the proper commutation for a DC series motor, or we should say the series motor, because in case of universal motor we have seen that we can apply series sorry DC or AC source for the starting of the machine. Okay, so commutation required for better power factor, better speed torque characteristics, and improved commutation. The low power factor in uncompensated motor is due to the presence of the transformer EMF caused by the armature reaction flux. This EMF can be reduced or eliminated by means of a compensated winding suitably distributed in the stator slot. Okay, so that means when there is a armature reaction that is new, that is so the thing is that in the stator section we have a field winding, okay, and we are thinking of a motor, and over the rotor we have the another winding. So now in case of motors, what we do, so in case of motor we know that there we have to give electrical supply as input and we will take mechanical energy as output. So when we are giving electrical energy as input to the stator winding, that is the field winding, so it is generating some flux. So that flux is cutted by the armature winding, and when that armature winding is cutted, the flux, it is generating some EMF. And when this when this rotor winding is connected to some sort of lobe, so here also some current flow, and due to that current flow it is itself generating some flux. And so that means we can think of like that way. So in the stator we have a flux, in the rotor we have a flux. Okay, so this generated rotor flux will try to destroy the main field flux. Okay, so the resultant of this main field flux is going to be reduced, but then as a result the overall efficiency is going to be decreased. So we never need this, we never expected this. So how we can minimize this effect of or eliminate this effect of armature reaction? So that's why this compensated winding is used. So and so that we can neutralize the effect of this armature reaction, and we can neutralize this armature flux. Okay, and so that the power factor of the system can be improved, the EMF generation can be improved. So those things can improved over there. Okay, so as we can see, there is a phasor diagram. So this is the phi d axis. Okay, and there is a main current IM. Okay, this is a VT is the terminal voltage, and this is the current flowing in the rotor section I, and in between them there is the phase angle, that is theta. Okay, and now there is a transformer action. Due to transformer BMF EMF is there, ETSD. Okay, and there is a short circuit current is flowing. Oh, this like this way we can find out and these are the drops due to the presence of resistance and due to the presence of reactance. So there are the some drops are occurring. So those things are represented in the phasor diagram. We doesn't need such details in this case, so I am not going for that details. Okay, compensated AC series motors. AC series motors are also known as the modified DC series motor, as their construction is very similar to that of the DC series motor, except their poles and yokes are thinly laminated for better magnetic properties. So lamination is done for reducing the eddy current loss and hysteresis loss. Okay, compensation is necessary because it increases the power factor, improve commutation, high speed torque characteristics. On the basis of the use of compensated winding, we have two types of motor, and they are written as like conductively compensated type of motors, inductively compensated type of motors. Once again I am repeating, conductively compensated type motors and inductively compensated type motors. Okay, so let us see what are those and what are the characteristics it has. So first we will start with the conductively compensated type of motors. In this type of motors, the compensated winding is connected in series with the armature coil. In case of large machine, we actually do this. The winding is put in the stator slot. The axis of this compensated winding is 90-degree shifted electrically with the main field axis. Okay. So that means in this case, with the field winding, that is in the stator section, this compensated winding is connected in series with the field winding. Okay, so that we can eliminate the cross magnetizing effect of this armature reaction. And now, so in the case of inductively compensated type of motor, so as the name suggested, that is there should be some induction. So induction when occurs, then when two coils, two circuits are not connected electrically, they are connected by magnetic means. So, so let us see what is written over here, then we are going to understand that one. In this type of motor, the compensated winding has no interconnection with the armature circuit of the motor. A transformer action will take place as the armature winding will act as primary winding of the transformer, and the compensated winding will act as a secondary winding. The current in the compensated winding will be phase opposition to the current in the armature winding. Okay, so a transformer action will take place in this case. Okay, because the both windings are not connected by electrical means, they are connected by magnetic field, magnetic strength. So the current in the compensated winding will be in the phase opposition to the current in the armature winding, definitely. So this is the, as you can see in the diagram, so with the field and armature winding, this compensated winding is not connected, as we can see in the right hand side picture. So there, whatever current will produce, that will be in phase opposition with the armature winding. So these are the two types we have. Okay, so universal compensated motor. So universal motor is a type of electric motor that can operate on either AC or DC power and uses an electromagnet as its stator to create its magnetic field. It is a commutated series wound motor where the stator's field coils are connected in series with the rotor windings through a commutator. Yes, it is there in case of universal motor. So in universal motor, the field coils are connected to the rotor windings to through some series oil compensated winding, so that the armature reaction effect can be minimized. Okay, so not all series wound motors operate well on AC circuit current. If an ordinary series wound DC motor are connected to an AC supply, it would run very poorly. The universal motor is modified in several ways to allow for proper AC supply operation. There is a compensated winding typically added along with the laminated pole pieces and opposed to the solid pole pieces found in DC motor. A universal motor's armature typically has far more coils and plates than a DC motor, and hence fewer windings per coil, thus reduces the inductance. So to improve what we make the change, so in case of universal motors, we use that compensated winding so that we can reduce the armature reaction. To improve the power factor, what we do, but we use the compensated winding. Then we though to reduce the reactance of the coil, because there are the coils. So to how we can reduce the reactance of the coil, so we know that resistance, or we know that that with the increasing length the resistance reactance of any wire is increasing. So if we can reduce, but the point is but the wire should have that capacity so that it can generate that amount of flux, so that it can, the system can be, the armature section can be magnetized. So for that purposes, what we do, what the change we make in case of this DC series motor, when we want to use that motor as a AC motors, that is we use lesser numbers of windings. Okay, so we use the lesser numbers of winding, and but the point is that here we use a thick wires. Okay, so that that where lesser turns of winding means lesser length of winding. Lesser length of winding means it has a lesser amount of resistance reactance inside that, and if we use thick, so it has a higher current capacity, and with the increasing current capacity we can say that the the magnetic field generation capacity will be increased with that one. So this is a very important point, that like this way we are changing this changes have to be done with this universal motor, with this series DC series motor, if we want to use as a universal motor. Okay, so now coming to the repulsion motor, so there are classified under single phase motor. In this case the stator windings are connected directly to the AC power supply, and the rotor is connected to the commutator and brass assembly. Okay, one of the types of repulsion motor is compensated repulsion motor. Its characteristics are discussed below. It carries an additional winding called compensated winding. In case of repulsion motor, that is with this additional winding is used, that is compensated winding, to reduce the armature effects. This is another two sets of brushes which are placed midway between the universal as usual short circuited brush set. Okay, so as we can see, so this is the stator section. Okay, it is connected with this is the armature section or the rotor section, and through there we are using this, there is AC supply. Okay, and there is another two sets of this is the brush. Okay, there is another two sets of brush as we follow my pointer. So these are the two brush, but another two sets of brushes are which are placed midway. This is the midway where we are placed this one. Okay, for the short circuit brush set, as a short circuit brush set we have placed in the midway of this rotor section. The compensated binding and this added set of brushes are connected in series. Okay, this here in this particular case the repulsion motor characteristics is that the not characteristic, the constructional feature is that the extra brush shade that we are using over here, with that we are connecting in series that compensated binding. Okay, so by using that one, that compensated binding, we can reduce the problems and we can overcome the problems associated with this series motor. So let us come to the advantages and disadvantages of this compensated series motor. Yes, it has a very high speed torque characteristics. How we are improving this high speed torque characteristics? By means of using this compensated winding. So when we are neutralizing the armature reaction, when we are improving the power factor of the system, so definitely at the time of starting, as so we can say that high current can flow through it, and if high current can flow through it, it can generate a high magnetic field, and due to that a high torque is can be produced. And when a high torque, we are thinking of a high torque, that means we can think of the machines can run at high speed. But one another point is there, that is it has also constant speed also. So improved commutation. So yes, definitely we have from the first till now we are discussing about these 2 points: improve commutation and increase in the power factor. So the type and pattern of windings we are using in case of, as we in case of this compensated winding, and the stator slot should be laminated. So like this changes if we make, so we can improve the commutation, and we can minimize or neutralize the armature reactions or brush sparking, heat generation. So everything we can minimize. Okay, so this is like this way we can improve the commutation, increase in power factor. So yes, definitely by using high grade where we can improve this power factor. So now let us see what are the disadvantages it has. So compensated motors on occasion have been known to run slow, overheat, or even fail to start. Okay, so that means sometimes it happens that compensated motors are overheated, because when we are thinking of a high thick wire, that means a high current can flow through it one, and it has a high torque speed characteristic. That means there must be some power loss inside that, and due to that there is a heat is generated, and due to that heat that the machine can run slow, and it will overheat it, and due to that some problem may occur and it may not run sometimes. So this may happens with each and every machine, but in this case a little bit more possibilities of doing so it may happen as we are using a thick bed. Cost and maintenance of this type of motor is very high. Yes, obviously with the field winding, with the rotor winding, we are using a extra winding, that is the compensated winding, so that overall improvement can be done, efficiency can be increased. So this definitely, this using this winding has some cost. We can the cost of overall cost of the machine can be increased, and as it has some commutator, we know that when there is a commutator and brass section, so the maintenance of the machine is increasing. So this this is very important. That one thing we can say that nowadays we know that instead of AC motor, instead of this DC motors, the AC motors are taking market. The reason behind is that the set, due to this presence of this commutator and brass set, because this commutator are very costly, as they are made of pure copper, and maintenance of this brass and commutator set is maintenance, regular maintenance is needed, so it is also costly. So these are the main disadvantages we have with regarding this compensated winding. So now coming to the conclusion. So what is the conclusion? The study of standard single phase compensated motors reveals a general increase in the efficiency and longevity of the magnetic parts of motors due to the substantial decrease in the cross magnetizing field due to the armature reaction. This is particularly prominent in the case of heavy duty induction motor, where power rating exceeds 200 kilowatt or more. Practical use suggests that compensated motors provide higher starting torque and improved power factor for longer use. Okay, so where we have to think of, yes, we want to use for a long 10 years, 20 years. So like that way, when we are thinking that, so if we are thinking for a long run, so though it has a high cost, high maintenance, so it can be adjusted if the machine is running for a long period of time. So the only prominent drawback of using compensated motors is their significant increase in the running cost and maintenance, which is pretty against the advantages offered. Hence, it can be concluded that modern industries and heavy appliances demand the use of compensated motors. So this is all for today. Okay, thank you.